In this video, I am going to explain you about priority encoder. In the last video itself, I already explained about octal to binary encoder circuit. In that, we faced two limitations and those limitations can be overcome by using this priority encoder circuit. So, here I am explaining a 4-input priority encoder circuit. Here, this is the truth table regarding 4-input priority encoder. In this, it consists of 4 number of inputs D0, D1, D2, D3 and the outputs are X and Y and one more output it is going to consist of, that is V. It is denoted as valid output indicator. Nothing but if we are applying any input value for the input of the circuit, this V output is going to be 1. If we are not applying any input value in the input side, this V output is going to be 0. Now we will see the combinations one by one. Now here for the first combination, I am not applying any input value in the input side. That means D0 equal to 0, D1 equal to 0, D2 equal to 0, D3 equal to 0. So the V output is going to be 0 here. And X and Y outputs are considering as don't cares. It is not indicating any binary code because we are not applied any inputs at the input side. Now we will consider the second combination by D0 equal to 1 and D1, D2, D3 are going to be 0. That means D0 binary code we may get at the output side. Here D0 binary code is 0, 0 and V output is going to be 1, means we applied one input at the input side. Now considering the other combination, don't care for D0 and 1 for D1 and D2, D3 values are at 0, 0. Nothing but we are applying D0 value, input value and D1 input value. Here D0 bit we may consider either 0 or 1. So based on priority, here we have to give priority for D1 compared to D0. So for D1 equal to 1 means that respective binary code is going to be 0, 1 here and V value is going to be 1. Now considering the other combination, D0 equal to don't care, D1 equal to don't care, D2 equal to 1 means here we have to give priority for D2 equal to 1. And regardless of D0, D1 values, whether it may be 0 or it may be 1, we are going to give priority for higher subscript numbers. So this respective D2 equal to 1 means that respective binary code we are writing at the output side, it is 1, 0 and V value is 1. And considering the last combination, D0 equal to don't care, D1 equal to don't care, D2 equal to don't care and D3 equal to 1 means in these all 4 inputs, we are going to consider higher priority input value, it is D3. And regardless of this D0, D1, D2, whether it may be 0 or it may be 1, we are going higher priority subscript numbers. That respective binary code is going to be 1, 1 at the output side for X equal to 1 and Y equal to 1. Now to draw the logic diagram for this 4 input priority encoder, we need to find out the Boolean expressions for X output and Y output and V output. To find out the Boolean expressions, we need to use 4 variable K-maps. So here I considered 4 variable K-maps for X, Y and V. And here we have to consider ones in the X output value. and we need to assign a don't care in the K-map itself. So here for the first combination D0 equal to 0, D1 equal to 0, D2 equal to 0, D3 equal to 0 nothing but it is indicating the minterm M0. Now here I already arranged the minterms in the K-map and here I considered row side D0, D1 variable and in the column side D2, D3 variables. So M0 minterm here this X value is going to consist of a don't care and leftover other combinations 1 0 0 0 means it is going to indicate the M8 minterm and this M8 minterm is having 0 means we are not going to consider that value in this K-map because in the K-map we may consider only ones and don't cares also. So this combination we are leaving here and coming to the other combination don't care 1 0 0 nothing but here for D0 we may assign 0 or 1. Here I considered that combination by considering here D0 equal to 0 it is indicating M4 minterm and by considering 1 here it is indicating M12 minterm. So for these two minterms also it is having a value 0. So this one also we are not considering in this K-map. And considering other combination D0 equal to don't care, D1 equal to don't care, D2 equal to 1, D3 equal to 0. Now in this combination we may consider these four combinations. Like don't care means we may consider 0 0, 0 1, 1 0, 1 1. In this manner we may find four minterms M2, M6, M10, M14. Now for these four minterms we have to assign a 1 value in this K-map. So M2 is 1, M6 is 1, M10 is it is here 1 and M14 is also 1. Now considering the last combination D0 is don't care, D1 is don't care, D2 is don't care, D3 equal to 1. Now in this combination we may find all these minterms like M1, M3, M5, M7, M9, M11, M13, M15. Now for all these minterms we have to assign 1 in this K-map. So M1 is here, M3 is here, M5 is here, M7 here, M9, M11, M13 and M15. Now we have to combine all these ones and don't cares. Now by considering the maximum number of ones here, we may combine these 8 ones and here also these 8 ones. Now the Boolean expression for X output is going to be D3 plus D2. Now in this manner we may find out the Boolean expressions for Y and for V also. By using those Boolean expressions we are going to draw the logic diagram of 4 input priority encoder circuit. Now we may find the Boolean expressions for output Y and V based on these output values. Now by considering all these combinations we may assign ones in this manner and by combining the maximum number of ones in this K-map we may find the Boolean expressions for Y equal to this one and for V equal to this expression. Now by considering these 3 Boolean expressions for outputs of X and Y and V, we may draw the logic diagram in this manner. Now here this is the logic diagram regarding 4 input priority encoder circuit. Now in this manner we may implement any priority encoder circuit based on the priority.